today. Okay, so we've been talking about series. That means when we start taking a certain number of terms and we add them up from a sequence. Okay, so a quick recap. Let's see, if we're dealing with arithmetic. Okay, there were two partial sum formulas that we could use. The first one being n divided by 2, the number of terms you're adding divided by 2, times the sum of the first number and the last number. Okay, that was one of our formulas. Okay, the other formula was if you didn't know the last term in your partial sum, so it was going to be the number of terms divided by 2 times double the first term plus the number of terms minus 1 times your common difference. Okay, so those were our two formulas if it was arithmetic. Okay, now if it was geometric, then we have two versions. Okay, two versions if it's going to be geometric. Now remember, we have a partial sum, S sub n, and we have an infinite sum. So the infinite sum was just S. Remember, there was no subscript n. Okay, so let me write that out. This one was the partial. This one was the infinite. That one was the infinite sum. Okay, so if you were adding a specific number of terms, then for a geometric sequence, it was going to be the first term times 1 minus r to the n, all divided by 1 minus r. Okay. Now, if it was an infinite number, this formula was even simpler. It was the very first term divided by 1 minus the common ratio. There was just one condition that had to be true if you were going to use this. In order to use the infinite sum, the absolute value of r has to be less than 1. Okay. If it's not, then you're not going to be able to find that infinite sum. Okay. So that's where we are. Let me see here. I think we were right here. Yeah, I think this is where we ended yesterday. Okay, so we have our infinite sum. Just a quick recap. What do we call that right there, that Greek letter? That's sigma. That's our summation notation that we like to use in math. Excuse me. Okay. Well, let's take a look at example 4. And actually, we don't have a whole lot of problems left on our notes, and we'll be done today. Determine whether the series converges. If it converges, give the sum. Okay. So you'll notice these are infinite sums. How do I know that? The top value was right above sigma. You have the infinity symbol right there. Okay. So if you're able to do this, the formula you're going to want to use is the one we were just looking at. A sub 1 divided by 1 minus r. Okay. Very, very simple, straightforward formula. Well, first, I basically wrote it down into 3 steps. One, you want to ask yourself, does it converge or diverge? If it converges, you can find the sum. You're good. If it diverges, the problem is over. You're not going to be able to do anything with it. Okay. So let's take a look at this one. Looks like I want to find the infinite sum of 3 times 0.75 to the k minus 1. Okay. So step 1. Does it diverge or converge? Well, the formula we have here is coming from a geometric sequence. That scalar is your first term. Okay. Well, it depends on the power. Let me go ahead and say that. Okay. In this case, because it's k minus 1, yeah, that's going to be your first term. R is going to be that base right there. Okay. Well, to go ahead and answer the question, does it converge or diverge, take that common ratio R. Is the absolute value of 0.75 less than 1? Is that a true or false statement? That's true. Okay. If it's true, that means it converges. Okay. So because it converges, that means I can actually go ahead and find what the infinite sum is. Okay. So 2, we've already identified the first term. We know that a sub 1 was equal to 3. Okay. We know that r is equal to 0.75. So 3, just find the infinite sum. So I'm going to use this formula right here. S equals, the first term was 3, divided by 1 minus r. So 1 minus 0.75. go. That's all you got to do. Now let's plug it into the calculator. Let's see what we got. That is a rotated conic, so you guys don't need that. That is something for IS. So control divide, we got 3 over 1 minus 0.75. Okay. So it looks like the infinite sum is 12. Okay. And that's it. That's all there is to it. Okay. Questions? What? Okay. We're good? Okay. Well, let's try this next one. Okay. Let me go ahead and take this off right here. Okay, B. So I want to find an infinite sum. Okay. Starting from n equals 0. So this one is slightly different because it just has the power n instead of n minus 1. But it's still really easy. First off, I want to go ahead and ask myself, okay, does it converge or diverge? Can anybody tell me what the value of r is? It is negative 4/5, right? So r, my common ratio, is a negative 4/5. So all it has to do is satisfy that condition. Is the absolute value of negative 4/5 less than 1? Yeah, 4/5 is less than 1. So because that's true, we said yes, I know it converges. Okay, I know it converges. Okay. And we can actually find the answer. Now remember, if it diverges, problem is over, can't use the formula. Okay. Well, let's go to step 2 here. Now in A, it was really easy to tell what the first term was. It was just a scalar. Well, here, we actually need to go ahead and plug in, kind of move that, plug in n equals 0. Because see, I'm starting with the 0 term, and that's actually okay, even though I said we weren't going to look at that ourselves. So if I were to plug that in here, negative 4/5 to the 0, what is that? What's anything to the 0 power? Oh, not 0. 1. Anything to the 0 power is going to be 1 every time. Okay. So I know that the first term is 1. We know that r is equal to a negative 4/5. Well, because it converges, we can use that formula. So all we got to do is plug in those two items. Remember, s equals the first term divided by 1 minus r. Okay, so the first term is 1 over 1 minus negative 4/5. But what happens when you subtract a negative? That turns positive. So let me erase this right here. Okay. And then now we just need to go ahead and figure out what that is. 1 over 1 plus 4/5. Okay, so I'm going to come on over here. So control divide. 1 over 1 plus parentheses, control divide, 4. Oh, that did not do that. 5. There we go. Okay. 1 over 1 plus 4/5. So the infinite sum should be 5/9. That's it. All there is to it. Anybody having a hard time? Anybody confused? Okay. All right. And I know what you're saying, Mr. West, we want some more of those problems. Okay. Here's a few more of those. All right. So determine whether the series converges. If it converges, give the sum. Okay. So same exact setup. So I want the infinite sum of 9/10 to the n power. See, I'm starting with the 0 term, going all the way to infinity. Okay. So first off, what is the common ratio? What is it? It is 9/10. Ooh, that's close. I mean, it almost got 2/10 in here. 2/10. Yeah. No. Okay, maybe. All right. So the question is, will the absolute value of 9/10 be less than 1? Yes. So that means this does converge. Because it converges, I can find the sum. Okay, so let's make sure we know what the first term is. A sub 1 equals, okay. Well, can anybody tell me what the first term is? It is 1. See, the lower boundary is 0, so I'm going to plug that in here. So 9/10 to the 0 is 1. Yeah. Okay, so we have everything we need. Okay, so the infinite sum, remember, is the first term divided by 1 minus r. Well, we just saw the first term is 1 over 1 minus r, so 1 minus 9/10. Okay. So I'm going to go ahead and do this. Okay, someone's already given me an answer. So I'm going to go back and change this so I don't have to type the whole thing again. Change that to a 9, change that to a 10. Okay. And I'm getting 10/19. I sure did. Okay. Let me go back over there and change that one more time. La, 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 la. Okay. Just seeing if you were paying attention, and I can't get anything past Lily Bell. Boom! There we go. She is absolutely right. I'm right some of the time. Get it some of the time because we're at it. Ah, there you go. Yeah, it's fun. Okay. So that one is 10. Okay. All right. So let's try B. Find the infinite sum of pi over 2 to the k minus 1. Okay. So what's that, Antonio? Why does this one diverge? Okay, so let's take a look. We know that r is pi over 2, right? So the question is the absolute value of pi over 2 less than 1? So let's go over here to the calculator. Let me go ahead and document B out of that. So control divide pi, okay, over 2 is actually 1.57. So he's absolutely right. 1.57 is not less than 1. Okay, that is not true, so no, it diverges. That means I cannot use that formula, so there is no infinite sum for me to find. If it diverges, you're done. Okay. All right, now C. This one says 1 plus a half plus a fourth plus an eighth plus ... Okay, well, let's see. Okay, first we need to know what r is. Now, remember here, they're already making it a series because they're just adding them, right? Remember, the original sequence is just 1, 1/2, 1/4, 1/8, and so on. It only becomes a series when you start adding the terms of a sequence. So how am I going to figure out what r is based on that? How have we done it before? Let me ask you this question. How do we keep the sequence going? What operation do we use? Like for an arithmetic sequence, we keep adding, right? The same number over and over again. Well, what do we keep doing for a geometric? Oh, not subtracting. We will divide. Because to generate a geometric sequence, you keep multiplying, right? So in order to figure out r, we have to divide. So I'm just going to take a couple of terms here, consecutive terms, like 1/2 and 1. So what's 1/2 divided by 1? That's just 1/2. Okay. Let's go ahead and take another pair just to make sure that it's consistent. Okay. Let's take 1/8 and 1/4. So I'm going to divide him by him. So r is equal to 1/8 divided by 1/4. What happens when we divide by a fraction? We multiply by the reciprocal. So I'm going to say 1/8 times 4/1. Okay, so that becomes 4/8, which is 1/2. Okay, so r is 1/2. Okay, now will it converge or diverge? Yes, because the absolute value of 1/2, that is less than 1, right? Yeah, so it converges. So can I use the formula? Absolutely, sure can. So let's see here. Let me give myself a little bit of room. So the formula, if it's an infinite sum, a sub 1 divided by 1 minus r. Well, what was the first term? 1, see, we already provided that, over 1 minus r. So 1 minus 1/2. Okay. In fact, can anybody tell me what that infinite sum should be? It is 2. That's it. Does anybody want me to show that in the calculator? How are we doing? Okay. All right. Well, there is one last idea that I'm going to go ahead and show you. This is how you take an infinite decimal and you want to go ahead and rewrite it as a fraction. You want to find what's equivalent to it. Okay. So the way you do this is you're going to go ahead and set up an equation. Let's start by saying that the decimal you're trying to convert is x. That's always our first step. So let x equal 0.234, 234, 234, dot, dot, dot. Okay. Now, what I'm going to go ahead and do is separate the number of terms that repeat from the rest of it. So how many digits are repeating here? 3. Okay. So after the very first time that it repeats, okay, the 234, I'm going to go ahead and put the decimal right there. I'm going to put the decimal following the very first time it repeats the sequence. And then we have 234, 234, dot, dot, dot. Okay. Now, we're going to go ahead and say this equals something times x. So you're going to have to multiply it by 10 or 100 or 1,000. But the number of zeros is the number of digits that are repeating. So how many numbers are you saying repeating here? It's 3. So I'm going to go ahead and say 1,000. Okay. If it were only 2 digits repeating, then it would be 100x. If it was just one number repeating, then it would be 10x. Okay. So now I'm going to break it apart at that decimal. I'm going to say 1,000x is equal to 234 plus 0.234, 234, 234, dot, 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 right? Okay. But does anybody notice anything? How do we start the problem? Yeah. We said that decimal we were wanting, the one that repeats, is just x, right? So I'm going to say 1,000x equals 234 plus x. And now I'm just going to solve for x. Okay. So let's see here. This would be, if I subtracted the x over, I'll go ahead and write it out. Okay. So 999x is equal to 234. And how would I solve for x? X equals 234 divided by 999. And there you go. Okay. And the only thing left is to go ahead and simplify it if it does. Will 234 over 999 simplify? I believe they're both divisible by 3. I believe that's it, yes. 26 1/11. Okay. All right. And then we can go ahead and test that real fast. If I go ahead and take 26 and divide it by 111, okay, control divide, 234, 234, and it's going to keep giving me that over and over again. Okay, good. Okay. Now, I only gave you one of those. Let me go ahead and give you another one, okay, for practice, and this will be our last problem today. So let's say I have the number, let's say 0.27 repeating. So let's say you have 27, 27, 27, 27, dot, dot, dot. So it just keeps repeating over and over again. Okay. So that number I want to go ahead and rewrite as a fraction. Okay. Well, the first thing I'm going to do is go ahead and move my decimal place. How many, on the last one I moved it 3. How many am I going to move it here? 2, you only want to go ahead and move it to the end of the first time your set of numbers repeats itself. So I'm going to go ahead and say x equals 27.272727 ... But what am I going to multiply x by? We multiplied the last one by 1,000 because we had to move it 3 times, right? There were 3 digits repeating. What am I going to do here? 100. The number of zeros is always determined by the number of terms repeating in your value. Okay. So now I just say 100x is equal to, I'm going to break it apart, 27 plus 0.272727. And now what would I do? There you go. By breaking it apart, that is the original value that I had, right? So 100x is equal to 27 plus x, and now you just solve your 2-step equation. So I'm going to subtract x. Okay, so 99x is equal to 27. So what does x equal? 27 99s. And will 27 99s produce? 3 11s. That fraction should have the same value as that infinite decimal. Oh, because what you're going to do, whatever number of digits you have that repeat, that's how many times you're going to move the decimal over. So here I moved it over here because, see, it repeated itself once, and then it just keeps repeating after that.
So every time, like, so it keeps repeating. So, like, oh, so since, like, the first one was 0.234.
Yes.
Like the first one.
So I would have said 234.234. Basically, I want to use the decimal to separate the first pattern from the rest. Yes, that's exactly right. That is correct. Cool. Okay, now I'm going to go ahead and give you the period tomorrow to work on this, but this is the assignment, so I'm going to cut it down for you. The homework that you picked up today, you only have to do 1 through 23 odds, and then 26, 28, and 29. Oh, somebody's taking a picture of the board. Oh, did you get it before I was in there? Oh, that would have made your phone even more valuable. Oh, Genevieve's going for it. See, I got a serious look on my face. I am? Yeah. Oh, that's okay. All right, but I'll go ahead and put that up again tomorrow. Okay. We'll probably even go ahead and do some problems together, and then I'll just let you guys do your thing. All right. Fantastic. Thank you guys very much. Good.